NXP, making embedded development easy for Linux snobs everywhere. Okay, we're going to talk about how to make embedded development simpler for robotics developers that are typically used to doing Linux designs. And Ian and Haku, you guys are going to explain, and not just explain, but also demonstrate some of these ways that it's easy to do real-time embedded design.
So we're going to show you two really interesting things here. For embedded developers, we've got on the B3RB, it's the microcontroller there is running Zephyr, and a subsystem on top of that called Cognipilot. And on the MELM, we're going to look at the battery management system that happens to be running NUTX RTOS. So both of these are POSIX-compliant operating systems. So it lets you be in the same environment you're used to when you're in Linux. So Haku, can you show us a shell? We're going to have a shell connected onto this. That particular board is called the CanHub K344. Can you show us what sort of things it could do?
Of course. So let me just type one command help first to show all the commands that actually is supported. And for example, you can see net is one of the command that actually is supported and are very similar to Linux.
So here we're on a real-time embedded controller, but it has a console and a shell that's very much like Linux, right?
Correct. So if I type net, you can see all these command options that basically just spit it out onto the shell screen over here.
Okay.
Okay, well, that makes a lot of sense, and that's all about Zephyr, a real-time operating system. But what about this other operating system running over here, NUTX?
Right. So NUTX is running on the battery management system, and that's all focused on real-time control of this battery. And now we're connected on with a shell to NUTX in exactly the same way as Zephyr. It's also POSIX compliant, and depending on how you write your code, you have the same sorts of examples interfaces. So Haku, what do you have on the console now?
So I will likewise type help again. And as you can see, it spits out all the command options that is supported on this platform.
Okay. And then it looks like at the bottom, we've got some ones that were built specifically for the BMS.
Correct. So if I go SH or many other commands that you can actually see, we can basically type, for example, PWD, which shows the current directory.
Working directory, yeah. BMS, how about the BMS command?
Sure. Let me try that one.
And I think BMS help will show you everything, right?
That's correct. There you go.
Right. So those are all the functions that were built into your real-time battery management system. And it's very accessible and easy, and it's quite unusual to have that level of access into a real-time embedded controller. Yeah.
Okay, so what we've learned is to make it easy for developers that are typically Linux developers. Doing embedded design is no different when they're using these modern RTOSs like Zephyr or NUTX.
Exactly. Yeah.
Now, we've also, in mobile robotics, talked about Cognipilot and Zeno.
Right.
And so how does that fit into this embedded development?
Well, that's another big advantage of these kinds of, building up on top of an RTOS like this. You get still the real-time performance, and then applications become more portable. So Cognipilot is a model predictive control software for this type of robotic system. And because it sits cleanly on Zephyr, it can run on the CanHub K344, but it can also easily run on the VMU RT1176. Anything that's already running Zephyr, you can is literally move the application over and it'll still run.
Great. And I think also with these modern RTOSs, there's more capabilities,
Yeah.
right? So what are some examples of those additional capabilities?
We all, when you used to do embedded development, is to try to fit the smallest little application in a microcontroller, and you just have a loop or something like that. But we know that, you don't buy a thermostat anymore, you buy an internet connected thermostat, and who knows what management's going to ask you to build next. So communication stacks become critical. And certainly in robotics, everything has to be connected to each other with either CAN or Ethernet or wireless. And you really need an RTOS like this in order to enable those types of functions.
Makes a lot of sense, yeah. So it's kind of future-proofing or giving you the flexibility to add more capabilities in the future.
Absolutely, yeah.
Okay. And, another thing we've talked about is scalability. So does working in RTOSs and doing embedded development help from a scalability?
Sure. I mean, for example, like Zephyr runs on all of our MCX processors. So whether you pick the right one, the right feature set, and you will still have the same programming interface into that.
It's scalability, but it also helps you really architect your products from a platform perspective because you're able to build one platform and then have different SKUs that use different parts, and you can use the same software base basically and migrate back and forth.
Yeah, exactly. I mean, pick the exact right part that has the feature set that you need.
Yeah.
I think the last thing we should mention is, because these are open source communities, there's a lot of developers adding code into that ecosystem, which means sensors and actuators and different things you might need to interface. There may already be drivers written for it, and very likely there are.
Yeah. So it's, again, simplifying the development process. So we talked about the things that can make it easy to do embedded design if you're used to a Linux environment. But talk about something that we might be seeing coming in the future. I think we talked a lot about in mobile robotics that safety is a very critical aspect. So how does the RTOS environment help support that requirement?
Right. There's a lot of work towards getting safe operating systems, and it's not easy. And so there is activity within the Zephyr community to move towards safety certification. There are some longer-term safety trends with things like Rust and Rust-based RTOSs, but it's definitely on everyone's mind as to what level it needs to be in terms of safety certified operating systems.
Well, there you have it. How to make it easy to do embedded development design, even for Linux developers. For more conversations at the edge, click on the links below.